What would you rather? Suppose you played the entropy game, the entropy of English, and I said, look, you can bet on whatever symbol you want next, put a proportion of your wealth on it, and you get to keep that wealth. No odds whatsoever. Well, your money will just be going down like, exponentially fast. Because the best you can do is keep the wealth you had on the symbol that turned out to be true. So that's, if we multiply everything by 27, now there's the fair odds for here, then all of a sudden you see your money growing. It's just an illusion. 27 times P and P are the same animal. The 27 factors out. The odds are irrelevant. Yeah. But as a motivational, I think it's nice to have the odds in so that you're actually making money. The 20 and the 27 to the nth balances out the exponential decrease due to the fact that you can't pick the best horse, the winning horse every time. All right. Let's see. Let me. Yes. Okay, here are a couple of nice facts. Let Sn star equal, say, 27 to the n times P of x super n. What that string of n letters is. Now, the expected value of anybody else's wealth over this wealth is the expected value of (27 to the n) b of xn over 27 to the n, see them canceling out, times p of x super n. These cancel, and so this is the expected value of b over p. But that is the summation of p of xn, b of xn, over p of xn. These cancel. But b of xn is any other gambling scheme, non-negative, summing to 1 of what you bet on that sequence. So, the expected ratio of any other gambler's wealth to the wealth associated with the log optimal or growth optimal gambler is 1. The new numeraire, what's a numeraire? Dollars, euros, it's what you use as the base of your money system. So here it would be in shares of that. Okay. Now, this is actually less than or equal to 1. Why? Because this is over the support set of P, support of P, which may include some x's that have positive B, but for which P is 0. So that's less than or equal to 1. So that means, fact, probability Sn, somebody else's wealth, is greater than the log optimal wealth is less than or equal to 1 over T. So, thus, B star equals P is competitively optimal. Which is to say, you can't outperform it by very much, with very high probability. In fact, in the text, we actually changed this to 2T. Yeah.
What's T?
T is any number greater than 1. And the reason for this is called Markov's inequality. Markov inequality. If y is greater than 0 and the mean of y is, say, mu, the probability that y is greater than t times its mean is less than 1 over t. If you have $1 and you're involved in and the mean gamble mu is 1, the probability you can turn $1 into $10 is less than 1/10. That you can turn it into $20 is less than 1/20. Yes.
T inside that probability, this fact.
Yeah, there's a T here.
No, above it. Okay. I'll let the next one up.
Thank you. T. No wonder people are asking what was T. This is T times S star. So we can apply it immediately to the English. The probability you can turn $1 into 10 to the 75th dollars in fair gambles is 10 to the minus 75th or less. By the way, the distribution that does that is this. You start with $1. Here's T. Here's mass 1 over T. All the other mass is at 0. That achieves this with equality when mu equals 1. And anything else does worse. Now, it turns out that Sn over Sn star is a martingale. Which means essentially expected value of Sn plus 1 over Sn plus 1 star, given x1 through xn. So it's a martingale with respect to the x process. This is equal to Sn over Sn star, which you can, since you know x1 through xn, you know what this ratio is. So you get to apply Kolmogorov's powerful theorem that says, fact, the probability that the largest value, sup means maximum, over n of Sn over Sn star is greater than or equal to t, we know the mean of this is less than 1, is less than or equal to 1 over t. And you do this by stopping the process when you hit t or 0. And then the expected value of the stop process has to be what you started with, because it's a martingale. Well, the beauty of this is, look how much stronger a statement this is than that. This says at time n, the probability your t times its grade is less than 1 over t. This says the probability that you are ever ahead by a factor of t, the opposing gambler, is less than 1 over t. So that means you can do optional stopping in an experiment like this. Or, in retrospect, look at the highest likelihood ratio you had, and you get essentially the same result. So, by competitively optimal, I mean, if you gamble growth rate optimal, and you, then roughly speaking, anybody who gambles in any other way will have more money than you, less than or equal to half the time. And by symmetry, since they're both gambling on the same thing, he can win, half. He can hold you to half the time by using the same scheme you use. All right. So now we have the fact that the best short-run behavior, that is just trying to walk out of the casino with more money than your opponent, is compatible with the best long-run scheme, which is, I want my money to grow to infinity at the highest possible rate. Both cause you to use proportional gambling. By the way, on this experiment here, some of the people only made 10 to the 70th dollars, some 10 to the 71th, but one made 10 to the 76. When you average 10 such amounts, the highest exponent pretty much swamps the others. And so you do as well as the best of the people. And you say, what can you do? And is that legitimate? Yes, it's just like mixing the gambling schemes. You give each person 1/10 of the money if you have 10 gamblers. And they each use their favorite thing. They get their favorite exponent. Then you add it up, divide by it. So the mixture of the gambling scheme gives you the mixture of the wealths. All right. Now let's talk about data compression. Chapter 6. Data compression. Chapter 6. Let's look at Morse code. E is a single dot. S is 3 dots. O is 3 dashes, etc. Q is a bunch of things. So why did Morse come up with this? If you can only send dots and dashes, actually all you can send is ons or offs. But a dot is like 2 ons and a dash is like 3 ons in a row. and a space between